Now there is another concept is coplanar parallel forces. Coplanar parallel forces. Under this, but coplanar forces and their line of action must be in one plane. Forces and their line of action must be in one plane. That is coplanar parallel. So there are two conditions. Coplanar nothing but all forces and their line of action must be in one plane, and their line of action is parallel to each other. All forces are in one plane, but their line of action is parallel to each other. So this is called as coplanar parallel forces. Now coming to here, so non-coplanar parallel forces. Non-coplanar parallel forces. Take example, suppose it is a spatial coordinate system. It is a spatial coordinate system. It is a spatial coordinate system. Non-coplanar means forces are acting not only in single plane, it must acting in different planes. Now suppose here is a one force is acting here. It is in vertical plane. There is another force is here in profile plane. There is another force is acting here. But the line of actions are parallel to each other. So here is non-coplanar parallel forces nothing but forces and their line of action must lies in different planes. But the line of action of the two forces or more than two forces is parallel to each other. So this is called as non-coplanar parallel forces. Non-coplanar parallel forces. So next one is coplanar. Now coplanar system of forces, there is another concept is here. So then that is a coplanar non-concurrent and non-parallel forces. Non-parallel forces. So see here, but in this case forces and their line of action in one plane, but these forces and the line of action is not intersect at one point or nor parallel to each other. Not intersect one point or nor parallel to each other. So this is called as coplanar non-concurrent and non-parallel forces. But here, but all forces are in one plane, but the forces are not intersect at one point. The line of action of the forces are not parallel to each other. So this is called as coplanar non-concurrent and non-parallel forces. Coming to here also, non-coplanar non-concurrent and non-parallel forces. See here, similar fashion. So non-concurrent and non-parallel forces. Here in this case, non-coplanar system of forces. Forces and their line of action not only in single plane, but acting in different planes. It is a spatial coordinate system. That is a three-dimensional system. Force is acting here, force is acting here, force is acting here, force is acting here also. These forces are not intersect at one point, but all forces are more than one plane, but not intersect at one point nor parallel to each other. So these forces are not intersecting at any point, and also these forces are not parallel to each other. So this system of forces is called as non-coplanar, non-concurrent, non-parallel forces. So it is about the system of forces. So first of all, we will discuss about the concept of under coplanar concurrent forces system. Concurrent forces system. In this we are finding the resultant. What is the resultant of coplanar concurrent forces. What is equilibrium? For how to find out resultant of coplanar concurrent forces, and also how to find out equilibrium of a coplanar concurrent forces system. So first of all, for coplanar concurrent forces, so what are the effects of the body? Whenever the coplanar concurrent forces acting on a body, suppose if it is a body, coplanar concurrent forces are acting. Suppose here is a 10 newtons, here is a 20 newtons, here is a 30 newtons, this direction, again this direction, here is a 40 newtons. So because of the forces, the body may be moved in x direction, that is x coordinates, x direction. Suppose if it is x direction, see the directions. Now this is the x axis direction, this is y axis direction, perpendicular to both is a z axis direction. When because of this coplanar concurrent forces, the body may be moved in a horizontal direction or vertical direction. That is nothing but because of the coplanar concurrent forces, the body having translation either in x direction or in y direction. X direction or y direction, the body having translation. What is the meaning of translation? The body move either this direction or this direction. That means that is nothing but translation. What is meant by translation? A body may be change its position from one place to another place, or the body moving from one place to another place. That is called as translation. So here is because of this, because of coplanar concurrent forces, the effect of the body may be moved from one place to another place. So that is called as translation. So next one is, another concept is to prevent this translation. So we want to prevent this translation, we must apply the force. That is that we will discuss in equilibrium condition. So first of all, what is meant by resultant? What is meant by resultant for coplanar concurrent forces? Whenever suppose it is a body, whenever number of forces acting on a body, whenever a number of forces acting on a body, so it is a P1 force, here it is a P2 force, here is a P3 force, here it is a P4 force. Whenever number of forces acting on a body, all the forces are replaced by single force. This is it is a body. So all the forces, all the forces are replaced by single force. Suppose all these forces are replaced by, I am taking only one force, that is a P5. So because of these forces, whatever effect for this body, because of only single force, it also produces same effect. Whatever effect we got for this body, same effect we will get here also, because of all forces. Suppose this is a P1 force, this is a P2 force, this is a P3 force, this is a P4 force. Suppose if the body may be cracked here, the body may be cracked here. So similar, all the forces are replaced by single force, which produces same effect of all the forces. Whenever the definition of this one, whenever number of forces acting on a body, all the forces are replaced by single force, which produces the same effect of all the forces. This single force is called as resultant of a forces, resultant of these forces. So this is a resultant of a force. This is a resultant of a force. Suppose for how to find out resultant of coplanar concurrent forces. Suppose if one force is acting here, this is a F1, there is another force is this is F2. So I will draw the parallel line, whatever the here, suppose here is O, here is A, this is F1 force, OA, here is a B. I will draw a parallel line. So there is magnitude, suppose if it is F newtons, for this force is F newton, this is F2 newtons. So I will draw a parallel line here also. This is also F1. So I will draw a parallel line here also. This is also F2. So if suppose I am making a triangle is like this. It is a triangle OABC. So from this triangle, it is a triangle from the triangle OAC. So this is here is I am taking here is theta. It is opposite side. It is adjacent side. So it is a hypotenuse. From this, how to find out the resultant? So how to find out this hypotenuse square according to Pythagoras theorem? According to Pythagoras theorem, R is equal to square root of F1 square plus F2 square. Here is a 90 degrees. Here is a 90 degrees. So now similar fashion. So here is from this, what is the magnitude of this force? So magnitude is for this resultant, magnitude is this one. What is the direction of the resultant? From this. So what is the tan theta? Tan theta is equal to opposite side divided by adjacent side. So that is F2 divided by F1. So theta is equals to tan inverse F2 divided by F1. So it is a one way by using Pythagoras theorem. It is a one way. So here is this force, and this force is replaced by single force. So whatever the effect produced on the body because of these forces, so same effect produced on the body because of this resultant. So this R is called as a resultant. So this R is equal to resultant of a force. Now coming to here, from this triangle, so there are different methods to find out resultant of a coplanar system of forces. There are different methods to find resultant of coplanar system of forces. Coplanar system of forces. First one is graphical method. Second one is trigonometric method. So another, there is a last method is analytical approach. So first of all, we will discuss about the concept of to find the resultant by using a graphical method. So under this graphical method, there are three different methods. The first one is parallelogram law of forces. Parallelogram law of forces. So second one is triangle law of forces. Next, third method is polygon law of forces. So first of all, we will discuss about the graphical method. Under this parallelogram law of forces. Suppose the two forces are, this is a F1 force, for this 100 newtons. There is another force is here. There is another force. Here it is F2. Here is angle is theta between the two forces. Here is a 50 newtons. So first of all, you convert this into scale, suitable scale. So I am taking 10 newtons is equals to 1 centimeter. 10 newtons, I am taking a scale. 10 newtons is equal to 1 centimeter. Now, for this force, how many centimeters? 10 into 10, that is equal to 100. So, that is equal to, here is a 10 centimeters. Now, it is a 5 centimeters. First of all, draw a line with 10 centimeters. So, here is a 10 centimeters. Again, here is the angle, here is put angle here, theta, mark theta here, draw the 5 centimeters line here, draw a line parallel to this force. Suppose it is a F1 force, it is F2. F1, we will draw F2, F1 with, here is theta, F1 is equal to 5 centimeter, 10 centimeters, sorry. So, F2 is equal to 5 centimeters. Draw a line parallel to this one. Draw for this F1 force, we will draw a parallel line here. This is also 10 centimeters. For this F2, I will draw a line, another force here. This is also 5 centimeters. Now, here is O, here is A, here is a B, here is C. Now, there is a diagonal here. This is a parallelogram. The diagonal passing through this point. So, this is a diagonal of the parallelogram. So, it is a parallelogram of forces. This diagonal represents resultant of these two forces. So, first of all, by using suitable scale, we are drawing F1 is equal to 10 centimeters, F2 with the angle, put suitable angle theta here, draw another force is F2. So, draw a line parallel to here, similar 10 centimeters dimension, here also 5 centimeters, here also 5 centimeters. These two are parallel, these two are parallel. Now, so by joining this point, so this is called as resultant of these two forces. Now, this diagonal of the parallelogram passing through this concurrence. Here is both forces are concurrent here. The diagonal of the parallelogram passing through this point represent resultant of these two forces. The statement for this is whenever two forces acting at a point, these two forces are adjacent sides of a parallelogram. These two forces, this force and this force, these two forces are adjacent sides of a parallelogram. So, the diagonal of the parallelogram passing through the concurrency, this is a concurrence point. The diagonal of the parallelogram passing through the concurrency represent resultant of these two forces. Resultant of these two forces. So, this is a statement of parallelogram law of forces. Parallelogram law of forces, that is nothing but two forces are acting at a point. These two forces are adjacent sides of a parallelogram. This is this is adjacent side. The diagonal of the parallelogram passing through this concurrency represent resultant of these two forces. It is a one method for finding the resultant of the two forces. There is another method, triangle law of forces. There is a, suppose, similar fashion. Next one is triangle law of forces. Triangle law of forces. Triangle law of forces. Now, here is a one force. Suppose one force is this one. This is also similar fashion, 100 Newton force. There is another force is here. So, there is a F2 force. Here is the magnitude is 50 Newtons. So, angle between the two forces is equal to theta. So, first of all, we will discuss about this concept. So, draw a line. Now, here is a draw F1 with a suitable angle. That is nothing but 10 centi. So, 10 Newtons is equal to 1 centimeter. 10 Newtons is equal to 1 centimeter. What is F1? F1 is 100 Newtons. So, that is equal to 10 centimeters. So, first of all, draw a line 10 centimeters. Again, mark this theta, it makes an angle with this force, makes an angle theta with horizontal. So, draw a line, here it makes an angle theta with a horizontal. So, this is F2, this is F1. So, by joining this point and this point, you will get this is a resultant of these two forces. Now, here is theta. It makes an angle theta here. What is the angle here? 180 minus theta. 180 minus theta. So, here is 180 minus theta. Now, this is a resultant of these two forces. Now, so it is a one force. here it is a one force, here there is another force is here. So this force is drawn by suitable scale. This force is drawn suitable scale. Now I am taking angle is alpha here. So what is the angle here? 180 minus of this and this is equal to this one. So here is you will get theta plus alpha. You will get here is theta plus alpha. Now this is F1 force, this is F2 force, this is F1 and this is F2. By applying sine law, so here is R divided by, so R divided by sine of 180 minus theta is equals to F1 divided by, so sine theta plus alpha, that is F2 divided by sine alpha. So we know either F1 and also theta, we are able to find out the resultant of a force. So here is it is a resultant. How to find out this is a way to find out resultant of the forces. So the definition of triangle law of forces. What is the definition of triangle law of forces? The two forces are acting at a point. Suppose if it is a one force, this is a one force. Here is this one, here is this one. Two forces are acting at a point. These two forces are adjacent sides of a triangle. Suppose one force is here. These forces are adjacent sides of a triangle. The closing side of a triangle. Suppose here is there is one force like this, there is another force is like this. One force. I am taking example here. So these two forces are adjacent sides of a triangle. It is a one force, it is another force. It makes an angle theta here. These two forces are adjacent sides of a triangle. The closing side of a triangle represent resultant of these two forces. This is a closing side of a triangle. It represents resultant of these two forces, but this resultant force is acting opposite direction of these two forces. Yes, this is a statement. So two forces are acting at a point. These two forces are adjacent sides of a triangle. So the closing side of a triangle, suppose this is a closing side of a triangle. The closing side of a triangle represent resultant of these two forces. But this direction is opposite to these two forces. This force order is this direction, but resultant is opposite direction. But we are not able to observe here. Suppose I am taking, there is another way for this. Suppose if it is this one, it is a triangle. Two forces are acting at a point. These two forces are adjacent sides of a triangle. It is F1 and F2. So the resultant force, the closing side of a triangle, represent resultant of these two forces. It is acting opposite direction. These are same direction, but it is in opposite direction. So this is also, there is another method. So but we are not able to observe because there is a confusion here. Sir, there is a direction is here, there is a direction is here. We are taking same direction, but we are representing, we are in the definition, we are explaining opposite direction. So this is a triangle law of forces. Two forces are acting at a point. These two are adjacent sides of a triangle. So the closing side of a triangle represent resultant of these two forces. So this is a triangle law of forces. So the next one is polygon law of forces. 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 Whenever number of forces acting at a point, suppose if it is a F1 is equal to 100 newtons, F2 is equal to 50 newtons, this is another force, F2 is equal to 50 newtons. So there is another force is this one, F3 is equals to 10 newtons. There is another force is acting like this. This is F4 is equals to 20 newtons. So take a scale, suitable scale, 10 newtons is equals to 1 centimeter. First of all, take a scale. How many units for 100? So 10 newtons is equal to 1 centimeters. So how many centimeters for this 100 newtons? That is a 10 centimeter. Yes or no? So this is a 10 centimeters. Draw a line with 10 centimeters. So take a scale, mark this, set the scale parallel to this one. You draw a line like this. This is a parallel to this one. So this is with 5 centimeters. So with 10 centimeters, sorry, this is 10 centimeters. Next one is again how many centimeters here? So 10 newtons is equal to 1 centimeter. So for 50 newtons is nothing but 5 centimeters. This is equal to 5 centimeters. How many? Here is a 10 newtons is equal to 1 centimeters. So how many centimeters here? 2 centimeters. Here is 1 centimeter. Now take a scale, set parallel to this one. So here is a mark the scale. Put scale parallel to this one and transfer here. Draw a line parallel to that F2 line. Here is like this with 5 centimeters. Now again there is another force is here, F3 force. Set a scale parallel to this one and start from here, start from F2. So you draw like this with 1 centimeters. Again there is F4 is here. So that is 2 centimeters. So set a scale parallel to this one and mark here. So and move like this parallel to here like this, because this is moving forward direction. So by joining this end point, it is a closing side of a polygon. So the closing side of a polygon represent resultant of all these forces, but it is in acting opposite direction. So these are moving this direction, but it is acting opposite direction. So that is nothing but whenever poly means many forces, whenever number of forces acting at a point that are taking adjacent sides of a polygon, that are taking in order. So closing side of a triangle, this is a closing side of a polygon, closing side of a polygon represent resultant of all the forces, but it is acting opposite direction of all the forces. So this is a polygon law of forces. Clear? All of you clear? Yes. Now this is a graphical method. Next one is trigonometric method. Under this trigonometric method, to find out the resultant of coplanar concurrent forces, there is another method is there. So that is a trigonometric method. Under this parallelogram law of forces, parallelogram law of forces. So I am taking, there are two forces acting here. This is a one force. Here there is another force is this one. The angle between these two forces is theta. Now first of all, here is a one force. Draw one force is like this. There is another force is like this. This is F1. Here it is F2. Now draw a line parallel to this one here. Whatever length here also. So here is a draw a line parallel to here. This is also F1. It is also F2. Okay. Now the diagonal, suppose by joining this point, this is a diagonal. So O, A, B, C. Here angle between the two forces is theta. Now first of all mark the F1 and put angle theta and draw the F2. So draw a line parallel to this one here, draw a line parallel to this one here. Now here it is theta, angle between the two forces is theta. Now here is draw a line, draw a vertical line here, and a horizontal here. Project this one A, B, C, D. So from this triangle, here is a, from this triangle ODB, from the triangle ODB, by applying Pythagoras theorem. So OB square is equals to OD square plus DB square. Now whatever angle is here, here also same angle. Now for this theta, this is opposite side, this force is F2. So this is opposite side, this is adjacent side. From this triangle, this is opposite side, this is adjacent side. So this is F2 sin theta. From here to is F2 cos theta. From here to is F2 cos theta. Now from this OB square is equals to, what is OD? OD is nothing but OA plus AD. OA plus AD whole square plus DB square. DB square. DB square. What is OA? It's lot of listen here. OA is nothing but F1. AD is nothing but F2 cos theta. OB square is equals to, what is OA? OA is nothing but F1 plus, what is AD? F2 cos theta whole square. What is DB? F2 sin theta. F2 sin theta whole square. What is here? This is a resultant R. I am assuming that is R. R is equals to, here is A plus B whole square. A square. It is in a form of, all of you see here, it is in a form of A plus B whole square. So that F square A square plus B square plus 2AB, okay, plus F2 square sin square theta. From this, R is equals to R square, R square is equals to, here is a F2 square here, F2 square here, take a common F2 square, F1 square plus F2 square, I am taking common from these two words. So F2 square cos square theta plus sin square theta. I am taking F2 common here, so that F2 square plus 2F1 F2 cos theta. Now coming here, R square coming to here, R square is equals to F1 square plus F1 square plus, here is F2 sin square theta plus cos square theta is equal to 1 according to our trigonometry. So that F2 square plus 2F1 F2 cos theta. Now from this, R is equal to square root of F1 square plus F2 square plus 2F1 F2 cos theta. This is a resultant of these two forces by using a analytical method. It is a, so here is a, so analytical method to find the resultant of forces by using parallelogram law. So again, here is alpha, I am taking, this is a resultant, magnitude of the resultant. I want to find out what is the direction. Direction means nothing but, so at what angle this force is acting from horizontal, that is a direction.